Wait a minute.
Why don't we do prom queen and king?
Do we have a packet?
We did.
We did. JC was the queen.
Homecoming.
All right, we do. Like last year, it was Kelsey and Colton.
Okay, a couple things. One, Tuesday,
It's
we will
only
dissect
16.
sheep eyes. Okay, so make sure you're ready for that on Tuesday.
I thought you said you didn't have time. The sensory system.
Oh, I forgot you're pregnant.
Where's the baby at? Like, did it already start kicking you?
Oh, yeah.
How many months pregnant are you?
About, I don't know.
Remember when
5
we
and a
couldn't
half.
know this?
Really?
Do you know what you're having yet?
Dude,
Wait,
I was
Oh, I knew
about,
that.
like,
You told me.
super
They
fast.
start kicking at what?
She's gonna
What
make
age?
it Tommy B.
What time?
Two is a
about
lot.
18 weeks.
I literally knew anything but
That's
that.
Moses' grandpa.
I don't
He lived
care.
to 102 years old.
All right,
Say
Boy.
that Tommy Bean.
okay, listen, if the more you talk, the less the video will pick up. So,
Oh.
I mean, if you have something to ask it, but don't be talking while I'm talking. DI. So Tuesday we will dissect eyeballs, probably my favorite dissection of the whole year. Tomorrow you're going to get a new chapter packet, so you'll have some class time to work on that. Monday, same thing. Then probably Wednesday we'll lecture over the ear. Thursday it'll be a video lecture. Thursday we'll do smell, and this is all next week. Thursday we'll do smell and taste. Friday there's a lab that goes with smell and taste. And then we'll probably have the test the next one next. There's a flex day in there somewhere too. Kind of do like we have been doing where we go over the review together. Go over the chapter packet together. Okay. So you probably want to take some notes on here because this PowerPoint is not very detailed. So we're going to look at anatomy of the eye, vision, and how it works. So external structures.
That thing's not on if that's what you want.
Okay, external structures of the eye. So a few things to look at specifically. Tarsal glands. So these actually secrete like a really oily secretion into your eyelid. So acts as a lubricant, so you can move your eye around. It doesn't just get hung up on the back of your eyelid. That would be painful with it. Like dry eyes, Those commercials always bother me.
Try on.
Where's it
Why do you
located?
keep looking like that?
Me?
Yeah.
I don't know.
Stare at this if you're going to stare at something. Okay, ciliary glands. So these are modified sweat glands between your eyelashes. And they're going to do the same idea. Same idea as like lubricate the eye.
I tried to fix it, but it didn't work.
It's kind of hard to put it back in place. I have my eye on you. So, the conjunctiva is an external membrane that covers the eye. So, anybody heard of conjunctivitis?
No.
That is the medical name of pink eye. Everybody's heard of pink eye, right?
Yeah.
So that is just an inflammation of the conjunctiva. So basically the conjunctiva, if you look on here, it's kind of like a double membrane sort of. So it's like you think about your eyelid. It covers all the inside of your eyelid, and then it wraps back around over your eyeball, and then it wraps back under your top eyelid. So it's like a layer membrane, like a double layered membrane. Make sense? So it runs along the inside of your eyelid, and then whenever it gets to the top of your eye, it actually covers your eye also. Like it flips over and covers your eye, and then it turns back and does your under eyelash, or eyelid, I'm sorry. Look at it. Look at the picture.
Okay.
Okay, so see how it's kind of double layered because
Because Kyle was looking at her like,
I know. It's underneath the eyelids, just a little membrane that protects under the eyelid, and then it curves back around and covers the eye itself. It doesn't cover the whole eyeball, just the external part that you can see.
Okay.
Oh,
Once you're-
I see what you.
So you
It's
know,
like that,
didn't we
comes
watch
back around,
didn't we
goes
watch
over.
a video of how they make fake eyes and put it back in it, or was that some other class?
Oh, I said y'all are doing the chapter packet tomorrow. Y'all don't have the video to watch tomorrow. I'm outside. I'm sorry.
You know, when they put like people that have fake eyes and they make them see again, they make another eye with a bunch of different stuff and they put it back in their eyes. Did they redo that part or no?
I don't know. I
You
thought
probably
they can
don't know
actually
about
make a eye that they put in to see again.
Uh-huh.
Now
I
lens,
saw.
yes.
What?
After this
Cornea,
Friday,
yes.
Neighborhood never.
I don't know. I don't know the answer. One. Okay, so that is conjunctiva. It also secretes like a lubricating fluid. Actually, it said lubricating mucus. There you go. It's eye boogers, I guess. I don't know.
Yeah.
So that's the conjunctiva. And then lacrimal glands. Anytime you see that word lacrimal, think tears. Remember we talked about the lacrimal bone right back here. Okay, so these are, there's a couple different, well, the glands themselves are way up here in the top, kind of outer part of your eye.
So why are they called like?
Tears. You produce tears.
Oh, and they come out here.
So that's
Well, tears come out. They have ducts at the top. The reason that you go, your tear duct, though, the one that drains your tears, is at the bottom, kind of in the corner. If you've ever looked in the mirror and pull down your lower eyelid and you see a little hole in there,
Mm-hmm.
you never done that?
Yeah.
Like, look in my eye.
Yes.
Yeah, and it has that
Yeah,
little
and there's a
hole
little
right
bitty
there.
hole right in the middle.
No, I've never.
That is your lacrimal duct. So it actually drains tears. So constantly making tears, but they normally drain. Whenever you get emotional or you start crying, then you're producing more tears than can be drained. But it's still draining really fast.
What if you don't cry? How's it drained then?
It just drains down in it, down into your nose.
Um,
So that's where you see this nasolacrimal duct. So all your tears drain into your nose from there. That's why when you cry, your nose runs.
Oh, that's so cool.
I've
oh,
never seen my brother cry one time my whole life.
Okay,
See,
so
my family has seen me cry so many times. I'm such a
I never.
I'm emotional.
I would probably
so
cry.
that's what happens with your tears. Tears are made of antibodies. Some of them. So they keep your eye fleshed out, right? Lysozyme. Any ideas on what that might be?
How you spell it?
Like Lysol,
Comes from the same base term. That's right.
like a Lysol.
Zyme makes you think enzyme. Lysosome, yes, does what?
Clean.
It cleans.
Clean.
That's
It's
right,
like
in
the
the
garbage
cell.
trucks.
That's exactly right.
Yeah.
Did you learn that in here? You weren't in here when we learned that, were you?
Yeah.
I think I learned that like freshman year in biology or something.
Yes, lysosomes are like the garbage truck cell in your cells. Okay, so lysozymes, they clean, right? They're enzymes that clean, and your tears have them in there, so it keeps your eye clean.
So it's good to cry.
I mean, it's good to cry, but that's constant. They constantly produce tears. You just don't. It doesn't always spill out because it's not producing them that fast. And then like a salty kind of lubrication for your eye too, which you know, if you've ever tasted tears.
Yeah.
They're pretty
Yeah, they're
nice thing. Yeah.
Salty.
All right, so that's that, and you can look, and you can kind of see everything else there.
Oh, there's muscle.
Okay, so extrinsic muscles. Makes you think what?
Exit.
Outer.
Yeah, outer. Exit can be going out, right? So yes. So there are 6 different muscles. You can see them on this guy too. Superior rectus. Remember, rectus means straight. So, and superior tells you that it's
Above.
above. Good. So this is the one above the eye. It would go straight back. So this gives you upward eye motion, right? If you contract that muscle, your eyes are going to go up. Makes sense. It shortens, pulls it backwards, right? Inferior rectus, downward eye motion. So this muscle down here contracts, pulls your eyeball down. Lateral rectus. Lateral means,
To the outside.
yep. So those are the ones close. I don't know about this. I don't know which direction it's going, but closest to the outside. So lateral motion,
Left.
can't do one by itself. Medial rectus would be,
Going just the middle.
yes, remember medial, middle,
Was it
Midline.
big?
Like crossing your eye.
Oh, okay.
or you think about it, while this lateral muscle is working, this medial muscle is working.
Oh.
If I look that way, see?
Oh yeah.
That's cool.
And then the obliques, remember we talked about oblique, that they kind of go across or circular, like we talked about with the lips and the eyes before. So superior oblique, superior means it is
Above.
above. So it's, look, it's like a circular type of, can't really see it as well on there, but it's circular. So it would help your eyes, I guess, turn, I don't know. And then inferior oblique is underneath, and you can kind of see that one better in the picture. See how it's round, like around the eyeball, kind of circular. Oblique usually tells you that it's a circular shaped muscle.
What does the inferior oblique do?
Let's see, what does it say? Upward and lateral. So, makes sense. Probably takes all of them. You start rolling your eyes, takes lots of muscle.
A lot of people say it looks like I roll my eyes a lot, but I really don't. I just look up.
All right, so internal structures of the eye, we'll have to add a little bit to these. First of all is humors. When you see that word humor, think liquid. Okay, so we have two humors in our eye. First one is the aqueous humor. It's the more watery of the two. Makes sense, right? Aqua.
Mm-hmm.
So look at this one. Have you ever looked at someone's eyeball from the side and noticed how like the center of it sticks out a little further? Okay, the aqueous humor is what's behind the cornea right there that makes that part stick out. You can kind of see it on 240 in the picture on 240. I don't know this one right here. Okay, so aqueous humor. Here's something, this outer portion right here is the cornea, which we'll talk about a little bit more in a second. Oh, wait a second. Okay, so that's the aqueous humor, and it constantly is like refilling with that fluid, like that fluid moves around. Okay, this part is the vitreous humor, and it's what really gives your eyeball its rounded shape. And it is thicker, okay, hence the name vitreous. And you will see it when we get those sheep eyes out Tuesday. You'll see the vitreous humor. It's not going to be like full and round like it would be if the sheep were alive, but you can see it. It's like gel.
So our eyes are like filled with juice.
It's like jelly.
Juice.
This is more like jelly gel. Jelly gel.
Like shapes.
Huh? Like shaving cream? Maybe. I would think more like
Hair gel.
not
Shaving
sticky,
cream.
but yeah,
Oh,
probably more like that consistency.
Jelly gel, like jelly is sticky.
I don't know. Yeah, I know. Anyway, I'm just trying to give you an idea of that consistency. But you'll see it. You don't even have to worry about what it's going to look like because you're going to see it. So that's the vitreous humor. If something happens to that vitreous humor, you're out of luck. Because it does not, that part will not repair.
what happens if that part is damaged?
It
Yeah,
damages
no.
your
Pretty
eye.
hard to get that damage though, right?
If you got stabbed with something, Nacho Libre with corn stuck in your eye.
Okay. But like,
I could do it.
So like, does it just make your eye misshapen or something?
Yeah, it would.
And then it would like all
Wait.
collapse in, and then you wouldn't be able to have
Yeah.
the eye.
look
So
at
you'd
that
like-
okay,
eyeball.
wouldn't you just go
I just
blind?
have it like really like stuck in there with nothing in it.
You have to like go through the middle.
That's in here.
Do you think you can still see with it doing like that, or do you think it'll shut down all their other stuff?
I just think it wouldn't work. Let's see. I don't see it in here, but I feel like I've heard that before. I might have made that up. Anyway. Let's keep going.
All right.
Back here. Vitreous humor, the vitreous body, helps prevent the eyeball from collapsing inward by reinforcing it internally. Aqueous humor is similar to blood plasma and is continually secreted by a special area of the choroid, which we'll talk about in a second. if drainage of the aqueous humor is blocked, you get glaucoma. I don't know, it doesn't say anything about vitreous humor, but I'm pretty sure that I read that before. Yeah. Just don't get your eyeball hurt.
Don't get your eyeball hurt, kids.
All right, let's keep going. So that's aqueous and vitreous humors. Okay, the tissue layers. So you can make your notes maybe on this slide, but I'm gonna go to
Miss
here so you can
Deckers,
see.
actually, so blame her.
I will. Okay, so tissue layers are tunics, and you'll hear that word again when we get to the blood vessels. Okay, but the sclera of your eye is the white of your eye. That's the outer layer of the eyeball. That's the white part that you see.
The what?
Pretty tough. Sclera is the white part of your eye.
Sclera.
Sclera.
Hey, Sclera.
It's on. It's at
It's
the.
on your paper.
Yeah, if you go back to
Oh.
here, I'm sorry. It's one slide above.
Can we start calling you that, Sarah? Sclera.
No.
Okay. The cornea, which is right under that, is part of the sclera. This is actually like a window into your eye. It's transparent. Okay, this is supposed to represent it, this clear part in the front here. Light passes through it, but get this, it has no blood supply.
But it lets blood
That's
in
crazy.
if you break it, right?
Yeah, if you got deep enough, it would bleed, yes.
Mine, I did. I put a dent in my cornea, and it started letting blood come into my eye.
So what are the issues with that? If it doesn't have blood supply, what does that mean?
It can't be. It can't heal itself.
Okay.
There's
Okay.
no oxygen in it.
No.
Okay, so normally tissue, if it doesn't get blood supply, doesn't get
Dies.
oxygen, and it would die. But
But
But that's not.
interestingly enough, it's not the case here, because the cornea, the aqueous humor that sits right behind the cornea, actually has a constant supply of nutrients and oxygen. So even though it's not blood, it still has
How do you
still
get that
gets all of
oxygen?
it. It just
That
does.
is
Just,
crazy.
the aqueous humor carries it.
There's no answers to this, though.
So, but that's how it
Yeah.
gets its nutrients.
believe it.
It's from the aqueous humor. So actually, the cornea repairs very quickly because it ggets those nutrients like immediately. Isn't that cool?
They were gonna laser my eye, like stitch it back together with laser, but they said it would just heal faster by itself.
Yeah, I know. Now, if you really injure your cornea, though, it can take a long time. Like I have a friend who, it's really a friend of my husband's, but he was chipping or like getting rid of tile in a house, didn't have on any goggles. Don't ever do that.
Gotta wait till you-
Tile hit his eye, major tear in his cornea, and it like spring. It's like when you tear it, it's like it's kind of elastic, so it like springs into place or pulls back. And he said it looked like he had like cellophane. I don't know what cellophane is, like clear plastic wrap.
Mhm.
Wrapped. It was like a big ball of that in his eye, in his vision all the time. So it's like you could see colors, but you can really.
You think that hurt a whole lot?
Oh yeah, they say it's very painful because it's got lots of pain sensors in it.
I wasn't wearing my glasses either.
So, okay, so that's, and your cornea can be transplanted from someone else. Interesting.
I knew that.
Okay, the choroid is the next layer down. It's kind of the middle layer. This includes the pupil and the iris. The choroid has a really rich supply of blood vessels. The iris is the colored part of the eye. So, oops. Colored, it's just the colored part, and it's all like muscle. That's the cornea.
Way to go.
Thank you.
Okay.
Oh,
You can
Corneal
get
damage.
all muscle.
So that's brown, right?
This one's brown, yes.
That's pretty good color to have your eyes.
That's ugly.
It is.
Yeah.
this.
Kyle, you brown.
Only
eyes.
Kinda gray
What
brown.
color are your
That's
My
supposed
eyes
to be
are
the
good
lens.
brown.
No.
Okay, so your iris is the part of your eye that gives you the color. Thanks for picking that up. And it's a muscle. It works like the diaphragm of a camera. Okay, the pupil is not actually a thing. It's just a hole. So when you look at someone's pupil, you're not looking at it, you're actually looking like at the back of their
You're,
eye.
like,
It's just
looking
really dark in
into it.
there.
But that's crazy.
It's like a window.
That is
So if y'all ever
insane.
looked at the end of a camera, like if somebody takes your picture with a camera and it kind of closes and opens, okay, that is works the same way as like your iris. Okay, and it's the same thing like aperture on a camera. Okay, the higher the aperture, technically I guess the lower number the aperture, the wider the opening is, the more light it lets in. And so same idea. So the iris, depending on how much light is in the room, opens and closes depending on the lighting situation. So yeah, I'm gonna leave this for you guys tomorrow or Monday through the day. This ophthalmoscope.
Ooh.
I can turn it on and look. Hold on, wait a minute. Shows you what I know. And you can look in each other's eyes. You can actually see whenever you tell them to look straight ahead and you come in from the side, and it will be really red. That's because you're looking at the retina when you look through their pupil. You're looking through their pupil to the back of their eye.
That's cool.
Okay, so I'll leave this out. You guys can play around with it. Okay. So that's the pupil. It's just that opening. There's two muscles. There's a sphincter pupillae, which is going to make it close. Dilator, pupillae muscle. It's going to make it dilate. Okay. Oh yeah, some of you guys missed this last week on the reflexes thing. The reason that a doctor has to put medicine in to dilate eyes, okay, is yes, so that they can see better, but I really wanted to know why that is, okay? But it's because, if you think about it, if you shine a light on someone's pupil, what's going to happen? It's going to constrict, right? And they're wanting to look at the back of the eye. So that's why, that is why they, think about it, they put that medicine in so that when they shine the light in there to look, it's not going to shrink up on them. They can actually shine it and look and see what they want to through a wider opening.
Last time I went to the eye doctor, they had this brand new machine that takes a picture of the back of your eye. They show you the picture.
That's cool.
I went to the doctor one time and they tried to do that, and they couldn't figure out why the thing wasn't working. And it turned out because they didn't like flip the switch to turn it on. I sat there for like 30 minutes.
Okay, you gotta keep going. All right. Other thing on here is the retina. The retina is the back of your eye. It's only located at the back of your eye. It doesn't cover your whole eye. Okay, it's the most internal layer. Innermost layer only. It's only on the back portion. It has very sensitive nerve endings, which we're going to talk about rods and cones in a second. So rods and cones are your photoreceptors. That's their name. They receive. They're sensory neurons, which means what? Sensory neurons or afferent neurons. What do?
Send to the
Send it to the
brain.
brain, right? So they pick up on light. Photo means light. So photoreceptors, they receive light, send the message back up to the brain. Look at the picture on 241. Okay, see how you've got the kind of the pigmented part of the retina, so that's at the wall of the retina, and then it's got the rods and cones there that are like purple and turquoise. So those are the sensory receptors. So light hits those and they pick up that message. Then they send it to those bipolar neurons. We talked about bipolar neurons last week or 2 weeks ago, whatever. Back to these nerve ganglions that go back to the brain to pick up and say, figure out. Your eyes don't really see. It's not like your eyes think, okay, I'm looking at Cody. They just see the blue and your skin tone and your hair, and then it goes back up to my brain and says, okay, that's Cody, because those are the things that's what Cody looks like. Does that make sense?
Yes.
Okay, so that is the retina. So rods are activated in dim light, so you see grays. Okay, your rods are being used. Cones see colors. I think C for cone, C for color. Pretty simple. Okay, so bright light, your cones are working.
Could you get your eyes to where you couldn't see colors? Like everything.
Some people make them that way, but you can be born that way.
I
Your
know,
cones
but I
aren't
want to know
working.
like who make it. And like you'd see everything in black and white.
Most of the time, people are missing one type of cone. Like they might be missing the green tone. the
Yeah,
green cone.
Like I know
or the
for
red
you
cone.
can't see that.
So colorblind.
Yes, that's colorblindness. So those things are in the back of your eye. Now there's one area called the fovea centralis. You need to write that one down because it's not in this new book. It's in the old one.
What is your
Fovea, F-O-V-E-A,
phobia? Is something that you're afraid of.
fovea. This
Oh.
is F-O-V-E-A.
This is an internal structure.
Wait, what?
Yeah.
Phobia.
How do you spell
F-O-V-E-A.
Oh, I
it?
put I.
F-O-V.
I did put I too.
Fovea centralis. Central. Yes.
What is that?
That is an area at the back of your eye, so your retina, where it has a very concentrated portion of cones. And that is where you see the best. Okay, so that's like a really concentrated area of photoreceptors. Cones, how do you want to say that?
Put an
Kind of
R.
like your prime vision spot. Now, there's another area at the back of your, or in your retina called the optic disc. And this is where your optic nerve, okay, hits the back of your eye.
You need to put that too.
Optic disc, yes you do. Okay. Have any of you guys ever seen your blind spot?
No.
So where your optic nerve hits the back of your eye, there are no rods and cones. If there's no rods and cones, in that area you can't see. I'm gonna tell you guys how to find how
Is
you
it-
can see your blind spot. So turn your paper over on the back.
I was like, isn't it where is it a black dot that comes on?
How do we see our blind spot?
She's about to show.
So put 2 dots on your paper, like good little size dots, maybe about 4 or 5 inches apart.
I think I did. It'll be all
Okay, so what I want you to do, cover one eye. So if you're covering your, let me say this, you're gonna look at the opposite dot. So if you're looking with your left eye, look at the right dot, okay? Hold it up in front of you. And you may have to move it forward and backwards a little bit, like hold it up in front of you and get it closer and away, and you'll be able to see your blind spot.
It just disappeared.
Monty, did you see it? Okay. You're going too fast, Sarah. Slow down.
Right there.
Okay.
I was trying to find it because it was like.
So
going
here's
in and
what's
out.
so crazy about that. So you have a blind spot in both eyes, right where your optic disc is, where your optic nerve hits the back of your eye. When you have both of your eyes in, even though one eye may not be seeing it, your brain automatically fills in the missing information.
That's crazy.
It's not there anymore.
I mean, even if I hold up this pen, okay, I don't go blind. My brain, even though there would be a blind spot on it somewhere, my brain automatically fills it in because, I mean, it already knows what it should look like.
Yeah.
Isn't that crazy? Cool.
Caitlin's gonna see this. in the
I don't know.
much.
I'll bet the pin.
Okay, so the other thing you need to add to internal structures is the lens. Okay, on here, this is supposed to represent the lens. So the lens is a convex shape, kind of like football shaped. Okay, it's right behind the iris. It's transparent and it's flexible. Now, when we get the sheep eyes out, you're going to be able to pretty easily find the lens. It's not going to be super flexible, okay, because the sheep is dead. So it's crystal-like, it's convex, it's held in place by, these are called suspensory ligaments. And they're connected to, it's called the ciliary body. And this is all in your book too. And those are all smooth muscle. So basically your lens doesn't stay the same shape all the time. Depending on what you're looking at, your lens can stretch or contract, not really contract, but your muscles can contract to see something different. Yeah.
So like when you have LASIK, isn't that what you're doing? You're changing the shape of it or whatever? your
I guess so, something like that. Yeah. So your normal vision is set for distant vision. So my eyes, when they're resting, they're set to see about 20 feet away. But if I'm looking at something closer, then those muscles contract and it stretches out the shape of that lens so that I can focus on it up closer. So that lens moves just a little bit.
Oh, that's a pretty cool thing.
Yeah, it is. Pretty cool. So that is called, oh, the ability for it to change shape is called accommodation. Accommodation.
Accommodate.
Right, it accommodates to the distance, right?
Is that squishy?
No, this one's not. This one's just plastic. It's just to show you the shape of it.
What?
Hopefully yours doesn't like shake around in your eyeball either, but. Okay, so vision, goodness, fast today. Retina, so this is kind of the order that light goes in, right? It hits your retina, the impulse is picked up by your photoreceptors, heads to your optic nerve, goes back through your optic nerve, towards your brain, through the optic chiasma. Y'all remember that kind of X-shaped optic nerves on the bottom of the brain? It has to optic chiasma, and then it switches over
Okay.
to your brain. Okay? And occipital lobe is where it's processed. It's part of your cerebrum. All right, real quick, eye injuries was not on here, but of course you can have tears, corneal tears. We already talked about that. The other injury, and these are in the book too, is a detached retina. So sometimes if you get an injury to your eye, you can have a detached retina, which is where that layer, that retina, that's the layer at the back of your eye, actually comes detached from the blood supply in your eye, which is an issue because the retina holds your rods and cones, so you cannot see without it. So it literally will be like a curtain, like depending on where the injury is. So if it's on like this bottom left side or bottom right side, it would like come up and I might not be able to see like that. Or if it was on this side, I might not be able to see like this.
So this would just be like black.
Don't want that. And let me tell you, if you think, and this goes for any kind of injury or anything or illness or whatever, there's something weird going on with your eyes, there's usually something going on. It could be a brain issue, but it could also be like a detached retina they can only do surgery on it for so long before it's permanently damaged. So it's something that you want to get taken care of. All right, vision disorders. These are on 244. Yeah. And then you can look at this chart is down there, and then there's some pictures we're going to use on 243. So myopia is nearsightedness, and that means that your eyeball is elongated. So if you're looking at it from the side, it would be longer this way than normal. And what happens is when light enters your eye, it kind of comes at an angle because it hits the lens, and then it breaks. You know, that lens like breaks the light. Well, normally it should hit directly on your retina. Like that's where those two, that should converge. You look at it at the top of 243. Okay, with myopia or nearsightedness, it means you can see near, you can't see far. You're nearsighted, that means you see near. Okay, so look, the focusing point hits way in front of the retina. Now, with hyperopia, it's too short. So the focusing point would actually be behind the retina. So that's what makes it blurry, is that it's not all focused in the spot where it's supposed to be focused. So that's why you get lenses, right? You get contact lenses or glasses because they correct then that issue. They can fix it from the outside, so they can go ahead and start bending that light to your lens.
Oh, no. Can't see anything.
Okay, does that make sense? Everybody good with that? Okay, presbyopia is age-related farsightedness. That's why people need reading glasses. Basically, what's happened is their ciliary body that should make their muscles contract, make their iris contract, right? Or their lens, I'm sorry, not their iris, make their lens contract isn't working. So they need reading glasses to be able to focus up close. Astigmatism is blurry vision. It's usually like a pointiness of the cornea or the lens, like it has an abnormal shape to it. Amblyopia is a lazy eye, so that means one eye is dominant. Sometimes the other one may cross, but one eye is dominant. They usually will cover up the dominant eye and make the other one work, make the other one see. If they don't get that fixed, though, a lot of times they can be permanent. I mean, it can cause permanent blindness. Diplopia. Diplo means two, so it's double vision. Abnormal alignment of the eyes. Strabismus is crossed eyes, or sometimes they just shake.
Already?
I know.
What is it when like your pupil is dragged down?